exercises of Chapter 6, Entropy and Free Energy. First, we will solve the multiple choice questions. Predict which of the following reactions has a negative entropy change. In reaction 1, we have formation of gas from solid. In reaction 2, we have formation of gas from liquids. In reaction 3, we have formation of solid from ions. So first of all, we have to know that the entropy increase when the disorder of the system increase during a transformation. And the order of the increasing order of the entropy as solid is less than as liquid, less than as gas. Suppose you obtain gases from gases, you have to count therefore the number of mole of gas formed if we have less or greater. So delta S in the question negative means the S of the products is less than the S of the reactants. So during the transformation, we pass from a system to more ordered system, so the product is more ordered than the reactant. In 1 and 2, we have appearance of gas from solid and gas from liquid, so the disorder increase. And therefore, delta S equal S final minus N initial is positive. In 3, we have ions that are not ordered that pass to solid which is ordered. And in this case, delta S is negative. So the correct answer is D. Exercise 18, MCQ 18. Which of the following is true for reversible, the free expansion of ideal gas? Delta S of the system positive, delta S surrounding equals 0, delta S system negative. All the above are true or all are wrong. What is the meaning of expansion? Expansion is a physical transformation without a change of state, where we increase the final volume, so V2 is greater than V1. And when the volume increases, the gaseous particles inside the container are more free to move. Their motion is easier. So these particles in the final system are less ordered. So S2 is greater than S1. So now what is delta S of the system during the expansion is equal to S2 minus S1. So in this case, the delta S of the system is positive. So the correct answer is A. Now we pass to another meaning. What would happen to delta S of the surrounding, to see if the answer B is correct or false. We know that during a reversible expansion, the heat is released from the surrounding to system. Why? Because during the compression, we made a force on the gases. So in the compression, we have release of heat from system to the surrounding. So in the expansion, this is the opposite direction. In the expansion, we will have release of heat from surrounding to system. So the surrounding lose energy. And when the surrounding lose energy, the particles, the motion of the particles decrease since the particles are close, and therefore the system in the surrounding passes to more ordered state, and therefore delta S of the surrounding is negative. So B is incorrect. Delta S of the surrounding is not equal to 0. During the expansion, delta S of the surrounding is negative. So in this case, the correct answer is only A. MCQ 90. Which of the following represents increase in entropy? Increase in entropy, so delta S is positive, so S final is greater than S initial, and S final is greater than S initial. So during this transformation, the disorder increase. And we know the order of the entropy: S solid less than the S liquid, less than S of ions, less than S of gas. So I will pass to analyze each of the statements. In A, we have a freezing of water. Freezing, that means we pass from liquid to solid. So we pass to more ordered state, which is the solid. So in this case, S final is less than S initial, and delta S is negative. So A is not the correct answer. B, boiling of water. The boiling is the transformation from liquid to gas. We have appearance of gas, which is less ordered. So S of the gas is greater than the S of the liquid, and delta S is positive. So B is correct. C, we have a reaction. We pass from 2 moles of gas to 1 mole of the gas. So delta N is equal 1 minus 2. Delta N is negative. That means the system passed to more ordered state, and therefore delta S is negative. D, B and C. So D is incorrect. Since B is incorrect and C is incorrect, we pass to E, crystallization of solid from supersaturated solution. We have a solution containing ions that is transformed to solid. So the order increase, and therefore delta S is negative. So the correct answer is only B. MCQ 20. Consider the following equilibrium at 298 Kelvin. 4HCl gas plus O2 gas gives 2Cl2 gas plus 2H2O gas. First, I have a remark. When they said consider the following equilibrium at 298 Kelvin, that does not mean that this reaction is at equilibrium. This is an equilibrium, but does not mean that now this reaction is at equilibrium. We have difference between consider the following equilibrium at 298 or consider the following reaction at equilibrium. When they said consider the following reaction at equilibrium, that means this reaction is at equilibrium. Now they said consider the following reaction or the following equilibrium. During this reaction, the disorder increase, decrease, disorder does not change. We need to know the temperature or none of these statements. First, I will start by A. The reaction is an equilibrium where all reactants and the products are at the gas state. So this is homogeneous equilibrium at the gas state. First, previously, before the reaction, we have 4 mole HCl and 1 mole O2, so we have in total 5 moles gas. And in the final state, in the products, we have 4 moles of gases. So the number of moles of gas decrease. Delta N is equal 4 minus 5. Delta N is negative. And when delta N is negative, so we have less formation of gas and the system is more ordered. So the order increase and the disorder decrease. So A is incorrect. B is correct. The disorder decrease or the order increase. So the correct answer is B. MCQ 21. Calculate delta S0 of vaporization in joule per mole per Kelvin for methylene chloride CH2Cl2, which boils at 40 degrees. The heat of vaporization is 31.7 kilojoule per mole. So first of all, we write the transformation. We have methylene chloride or dichloromethane liquid that is transformed to methylene chloride gas. What is the meaning of boiling or vaporization? Boiling is a phase transition where we pass from liquid to gas. So this is a physical transformation with a change of state at constant temperature. And when we talk about boiling, condensation, boiling, vaporization, condensation, melting, fusion, sublimation, crystallization, all these phase transitions are at equilibrium. So, at equilibrium, delta G of the transformation is equal to 0. And we know that delta G equal delta H minus T delta S. Pay attention, when we write delta G, we write delta H and delta S. Since in the formula delta G equal delta H minus T delta S, the 3 thermodynamic data, delta G, delta H, and delta S should be written at the same conditions of pressure and temperature. So delta G equals 0, delta H minus T delta S equals 0. What is the pressure during this transformation? This is a vaporization at the open atmosphere. Or the pressure is not mentioned, so I can suppose that the pressure is equal to 1 bar. In this case, I can transform delta H to delta H0 and delta S to delta S0. So the relation delta G equal delta H minus T delta S become delta G, pay attention, we have to conserve delta G, equal, instead of delta H we put delta H0, delta S we put delta S0. So the relation delta G equal delta H0 minus T delta S0 is equal to 0. Therefore, T delta S0 equal delta H0 and delta S0 is equal to delta H0 divided by T. Delta H0 is the delta H of the transformation. So this is delta H of vaporization and the value is given. The temperature is the temperature of the phase transition, is the temperature of the transformation, and also the temperature is given 40 degrees. So now we can calculate delta H0 equal delta H0 divided by T. So delta H0 in kilojoule, you obtain delta H0 in kilojoule. Delta H0 in joule, you obtain delta H0 in joule per Kelvin. We have to divide by the temperature. So it's preferred to transform delta H0 to joule divided by temperature 40 plus 273, so 313 in Kelvin, and we obtain delta H0 equal 101 joule mole minus 1 Kelvin minus 1. So the correct answer is C. MCQ 22. Consider the following reaction: Hg liquid, O2 gas, HgO solid, and delta G0 of the reaction is given. Minus 117 kilojoule per mole. And we have S0 of the reactants and S0 of the product. So we have to calculate what is delta H0 formation of HgO solid. Think about the strategy to solve this exercise. We have delta G0 given. We have S0 of the products and S0 of the reactants. So we can calculate delta S0 of the reaction, which is equal S0 product minus S0 reactants. So now we have delta G0 and we have delta S0. We apply the relation delta G0 equal delta H0 minus T delta S0, and the temperature is given 298. So we can find delta H0 of this reaction. Then we apply Hess law. Delta H0 of the reaction is equal to S0 products minus S0 reactants. So delta G0 of the reaction equal delta H0 minus T delta S0, and delta H0 equal delta G0 plus T delta S0. Delta S0 of the reaction is equal to the sum of S0 product minus S0 reactant, equal to S0 Hg solid, HgO solid, minus 2 S0 Hg liquid, minus S0 O2 gas. We put the values of S0 and we obtain delta S0 equal minus 216.5, pay attention, joule per Kelvin. I prefer to use the unit joule per Kelvin. Joule per mole per Kelvin mean per 1 mole of O2 reacted. So it's preferred to use only joule per Kelvin as unit. Delta H0 equal delta G0 plus T delta S0. Pay attention that delta G0 is in kilojoule per mole and delta S0 is in joule per Kelvin. So you have to do the conversion of the unit to kilojoule or to joules. So we obtain delta H0 equal minus 181.5 kilojoule per mole. We have to correct this value is kilojoule per mole. So now we apply Hess law. Delta H0 equal delta H0 formation of the product minus reactant equal delta H0 formation HgO solid, which is requested in this exercise, minus delta H0 formation of Hg liquid 2 times, which is equal to 0 since mercury is at the standard state is at Hg liquid, and delta H0 formation of O2 gas is equal also to 0 since O2 is a simple element. So we obtain delta H0 formation of HgO solid, which is equal to minus 90.75 kilojoule per mole. Pay attention, in this case, the unit should be in kilojoule per mole, since in the definition of delta H0 formation, we need formation of 1 mole of substance. So the correct answer is E. Exercise 23. The entropy of NH3, N gas, and H gas are the followings at 298 Kelvin. Using delta G0 given below, calculate the bond energies of NH. This is the same strategy as the previous exercises. The previous exercise 22, MCQ 22. We have delta G0 in the previous, we have delta G0 and we have delta H0. We calculated delta H0 of the reaction, then we apply Hess law. So we apply method number 2 in the calculation of delta H. Now we have delta G0. We can calculate delta H0. So we find delta H0 of this reaction. Then we apply method number 3. That delta H0 of the reaction is equal to the bond energy formation of the products minus bond energy formation of the reactant. And in this case, we find the delta H0 of the bond energy of NH, of the bond NH. So delta G0 equal delta H0 minus T delta S0, delta H0 equal delta G0 plus T delta S0. We apply delta S0 equal S0 products minus S0 reactants, and we find the value 304.7 joule per Kelvin. Delta H0 of the reaction equal delta H0 plus T delta S0. Again, pay attention for the conversion of units. So delta H0 of the reaction equal 1172.8 kilojoule. Now, apply method number 3, calculation of delta H of the reaction equal bond energy formation product minus bond energy formation reactant. Pay attention that we can apply this relation since the reactants and the products are all at the gas state. So delta H equal the delta H of bonds in the product. We don't have bonds in the product since N is atom and hydrogen is atom, so equal 0, minus the bond energy formation in the reactants. If we draw Lewis structure, we obtain 3 bond NH, simple NH, so minus 3 delta H0 of the bond NH, and therefore delta H0 of the bond NH equal minus delta H of the reaction divided by 3 equal minus 390.9 kilojoule per mole. Pay attention that your answer should be negative, since when you apply this relation, you use the bond energy formation, and the bond energy formations are negative. So the value should be negative side. The correct answer is B. MCQ 24, calculate delta G at 25 degrees for the following reaction: PCl5 gas, PCl3 plus Cl2 gas, when the pressures are as follows: P of PCl5, P of PCl3, and P of Cl2 are given. So this is a calculation of delta G of a reaction at given advancement, at a certain advancement. So we apply the relation delta G of the reaction is equal delta G0 of the reaction plus RT ln Q. Pay attention when using this relation delta G0 should be at the same condition of the temperature used in the formula. We have temperature equal 298 Kelvin and R equal 8.314 joule per mole per Kelvin. Q is the thermodynamic data, or the thermodynamic ratio, or the thermodynamic quotient, depending on the advancement, depending on the given pressures. And the Q is equal to the products over the reactants according to the stoichiometry. And pay attention, for solid, neglect the presence of solid and liquid. For ions, use concentration, and for gases, use the pressure. So Q equal P of PCl3 at the given advancement times PCl2 gas at the given advancement divided by the pressure of PCl5 So Q equals 16 times 10 to the power 4. So now we have a Q, we have T, we have R. We need to calculate delta G0 of the reaction to calculate delta G at the given advancement. So how to calculate delta G0 of the reaction, which is the standard free enthalpy of the reaction? In the explanation, I said that we have three methods. Method 1 is to apply delta G0 of the reaction equal delta G0 formation product minus reactants. And in this exercise, we don't have the delta G0 formation of the products or reactants, so we could not use this method. Method number 2 is to apply delta G0 of the reaction equal delta H0 of the reaction minus T delta S0 of the reaction. And pay attention when using this formula, delta G0, delta H0, and delta S0 should be at the same condition of pressure and temperature. So we can use, since from delta H0 formation of reactants and the product, we can calculate delta H0, and from S0 of the products and reactants, we can calculate delta S0. So we can use this method in this exercise. Method 3 is to apply the algebraic method. You have given reactions of known delta G, you calculate delta G of the global reaction. But in this case, we don't have reactions given. So we apply method number 2 in the calculation of delta G0 of the reaction. Delta G0 of the reaction equal delta H0 minus T delta S0, and delta H0 equal delta H0 formation products minus delta H0 formation reactants, okay, and delta H0 formation are given, so we obtain delta H0. By the same way, delta S0 of the reaction equal S0 product minus S0 reactants, and we calculate as delta S0 of the reaction. Therefore, we calculate delta G0 equal delta H0 minus T delta S0 of the reaction. Pay attention for the conversion of the units. Delta H0 is in kilojoule, delta S0 is in joule per Kelvin. You have to choose to transform to kilojoule or to joules. We transform delta H0 in this part to joules, and we obtain this value. So delta G0 is equal 37.15 kilojoule per mole. Therefore, we put delta G0 by its value, and we calculate delta G, which is equal to 66.8 kilojoule per mole. What is the meaning of this value? The meaning delta G of the reaction is positive, means mixing PCl5, PCl3, and Cl2 at the given conditions means this reaction is non-spontaneous.